All right. Next up to bat, guys, is solving quadratic equations. And we're going to solve quadratic equations. The test tomorrow, and this is not on the test tomorrow. And we'll finish this lesson on Wednesday in class. We're not going to finish it today, just kind of get us started. We're solving a quadratic equation. Now, when I give you this set of directions here, solving quadratic equations, what's the first question that we need to ask ourselves? What is a quadratic equation? Okay? How do I know what one looks like? Okay? What is a quadratic equation? Any ideas? When you see the word quadratic, what comes to memory? Yeah, Colt?
Isn't it a parabola?
It is a parabola, yes. Okay, I thought you were saying field goal, touchdown. Touchdown. Yeah? What did you say? The quadratic formula comes to mind. What is the quadratic formula? X equals negative b squared minus all over 2a. Yes. Where do those a, b, and c values come from?
First, second, and third.
The first, second, and third terms in the quadratic equation. That's exactly right. So a quadratic equation is any equation that can be written as ax squared plus bx plus c equals 0. Where the only condition we have here is that a cannot equal 0. A cannot equal 0. Because if a equals 0, the square term is not there, and it's the square term that makes it quadratic. Okay? Now, you guys already mentioned some other things that kind of come to mind. What are some other things that come to mind when you think of this? Holt, you said it's the graph is a parabola, right? You didn't say that word, but touchdown. Graph is a parabola. It's a U-shaped graph. Arch, okay, parabolic arch. What else do we know about it? Two answers, right? Yeah, two solutions. Why, Garrett? Because. It's a great mathematical argument. You've just changed the world.
It'd be like x plus 1 equals 0 and like x plus 2 equals 0. So you can separate them.
So you're getting up into the one of the methods of solving there, right? Factorization. Yeah. But what's the algebraic reason that this has two solutions? The x is squared, and according to the fundamental theorem of algebra, an nth degree polynomial has n solutions, so a second degree polynomial is going to have two solutions with repetition. You know, sometimes an answer is a solution twice, and we'll kind of discuss that a little bit when we get a little further into it. But there's all types of things. If you just remember the graph is a parabola, that graph has a vertex, it has x-intercepts, it has y-intercepts, it has a focus, it has a directrix, it has all these different things that you found in Algebra 2 that are related to the graph of the function. So there's a lot of characteristics of a quadratic function or quadratic equation that we need to know. We've already answered the second question. Solutions, we're expecting it to have two solutions because it's the second degree, and we'll go on from there. All right? Now, what are the methods for solving a quadratic equation? You mentioned one. Factoring. You can solve it by factoring. And we're going to cover all these methods in this order. Quadratic formula is going to be the last method we use, but it is on the list. You're right. You can always use the quadratic formula. You can't always factor, right? Because not every quadratic expression is factorable. Quadratic formula is probably one of the most important mathematical discoveries ever. It's really, really old, by the way. Okay, and you should look it up and see how old it is. Quadratic formula. Jagger, could you do that on your watch right now? Look up the. You can't do that. You can do a lot of other stuff, evidently. All right, solve by factoring. We can solve by taking square roots, using the square root property. And you guys will remember these are really pretty easy. If you had a problem like x squared equals 16, that's quadratic, right? What are the solutions?
Plus 4 minus 4.
Positive 4 or negative 4, right? X equals plus or minus 4. And this is the square root property that says, you don't need to write this because we're going to cover it in just a couple days. If x squared equals b, then x equals plus or minus the square root of b. Okay? That's the square root property. Yeah, Holt?
It's 400 BC.
400 BC,
What?
the quadratic formula. Yeah. So, I mean, I think I've told you guys this before. The newest math that you learn in high school is from the 1600s or 1700s. And we did it. Pascal's triangle, using Pascal's triangle to expand binomials, binomial expansion, the early part, is the newest math you learn in high school. You don't learn anything any newer than that until you get into the calculuses, advanced calculuses, and linear algebra, graduate school level math courses. Everything else we're studying is old. Quadratic formula, really 400 BC? I didn't remember it being that old, but that's pretty impressive that somebody figured this out that long ago. It really is. All right, x squared equals b, then x equals plus or minus b. It's impressive that anybody cared to try.
Yeah.
Right? 400 BC.
Who was it?
I got him doing.
It probably,
Garrett.
yeah,
Why didn't you just calculate?
Babylonians.
the Babylonians. Yeah, they gave us our alphabet, right? No, that we use the Phoenician alphabet. All right, off track. So we'll do square roots, solving squares, solving using square roots, and then the following one is my least favorite, and it will be yours. Solving by completing the square. Completing the square, this process is, every once in a while it's easy to do and advantageous to do it, but it's not a method that you're probably ever going to choose to use to solve a quadratic equation. But I teach it because I want to show you how to actually derive the quadratic formula by completing the square. So we'll use the completing the square method to take ax squared plus bx plus c, and this will be on your next test, equals 0, and come up with the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? This equation, when you solve by completing the square, you get that. Okay? So that's something that's going to be, it'll be new for you. You will have not seen it before. Okay, and you will be tested on being able to do it. All right, so those are the methods for solving quadratic equations. The first of those methods is the one that you're most familiar with, I think, and that's solving quadratic equations by factoring. All right, when we solve quadratic equations by factoring, it requires us to know this little ditty. The zero product property. Excuse me. What is the zero product property?
Anything multiplied by 0 is 0.
Anything multiplied by 0 is 0. That's actually the multiplicative property of 0, which is very similar to the zero product property. Okay? The zero product property tells us that if, oopsie, the zero product property says if A times B is equal to 0, what conclusion can we draw? Here's my hypothesis. If, then is the conclusion of this statement. What can we conclude if A times B equals 0? A equals 0 or B equals 0. Well, they could both be 0, but the or allows for that conclusion, right? If A times B is equal to 0, then A equals 0 or B equals 0. So if we're going to solve by factoring, factoring is getting to two things that are being what? What's factoring mean? If we're factoring an expression, what are we doing? breaking it down into what? Pieces that are being multiplied, right? A factor is something in mathematics that's being multiplied. So if we're factoring, then we're breaking an expression up into its multiplied pieces, right? And we want it to multiply to equal 0 so we can use the zero product property, right? If A times B equals 7, can we draw any conclusions? No. We can't draw any specific conclusions if A times B equals 7. We don't know anything about A or B. There's an infinite number of solutions to this equation, right? But if A times B equals 0, something magical happens. We know that A or B has to be 0. So when we're solving by factoring multiplied pieces, you struggling, Garrett? We're solving by factoring. We need it to be equal to 0. Okay. I have learned that lunch has a completely opposite effect on older students and younger students. My 8th grade students, when they come in right after lunch, bouncing off the walls. And the older you get, the tireder you get after you eat. I don't know what it is. So you go to lunch and you eat, and all that blood's rushing to your stomach, digest. But it doesn't have that effect on 8th grade boys, unfortunately.
Maybe they're vampires.
Maybe they are. All right. So let's power through. I know y'all are getting sleepy. X squared plus 5x plus 6 equals 0. We're solving this quadratic function and quadratic equation, and we want to use this method. If we're going to break it up into factors, multiplied pieces to solve, it has to be equal to 0. Well, we're good there because it's already given to us equal to 0, so we'll solve it by factoring x squared plus 5x plus 6. What is the factorization of x squared plus 5x plus 6?
-1, -5. Oh, darn it.
That would give you a -6, right? X plus 2 times x plus 3, right? X plus 2 times x plus 3 is the factored expression. So y'all watch. Is the zero product property in play here? Are we meeting the hypothesis of the zero product property? What was the hypothesis of the zero product property? If AB equals 0. Are we multiplying two things and getting 0? Yes. A times B equals 0. Right? Just we're multiplying binomials, but remember the grouping symbol, that's one thing and that's one thing. So if A times B equals 0, then either A equals 0 or B equals 0. And that means x equals -2 or x equals -3. Okay? Now, the reason that this is going to be so monumental for us or important is because the zero product property works whether we're multiplying two things or whether we're multiplying 15 things. Okay? So if I could break up a 5th degree polynomial into 5 binomials, I could set each binomial equal to 0 and find all 5 solutions. Okay? What is algebra again? It's the branch of mathematics where we learn the skills necessary to solve all types of equations, right? And it is based on the fact that the fundamental theorem of algebra tells us that an nth degree polynomial has n solutions. We're trying to find all 6 solutions to a 6th degree polynomial. Okay? That's a pretty big deal. Goes way back. All right. So set each one of those equal to 0 and we get -2 and -3. Now you don't have to check quadratic equations. It's not equations that you are forced to check. We're not looking for extra solutions here. But you can check those just to be safe and make sure it works. Last one and then we'll quit for the day. Almost there. X squared minus x minus 12 equals 0. Now, if I'm going to solve by factoring, I have to make sure that it is equal to 0 because I want to use the zero product property. There is no product property for 12, so if the 12 was on the other side, I'd need to subtract 12 to get it equal to 0. What's the factorization of x squared minus x minus 12? X minus 4 times x plus 3 is correct. Now the conditions of the zero product property are set, right? If a times b equals 0, if x minus 4 times x plus 3 equals 0, then either x minus 4 has to be 0 or x plus 3 has to be 0. If x minus 4 equals 0, x is 4. If x plus 3 equals 0, then x equals negative 3. Okay. Now again, you could plug those in and solve it if you'd like. Now, quick last question of the day. What are 4 and negative 3? What's the significance of 4 and negative 3 to the quadratic function? You plug it back in, it makes it equal 0, which means that these are they're not just solutions to the equation, they're also called zeros of the equation. Right? Call them zeros. Does that have an E? It does now.
It does.
It does now.
Oh.
Right there. This one does. I don't think it does it? I don't think it has an E. 0s. Yeah, I don't know. It looks bad too. Neros.
Doesn't heroes have any?
All right. You would think that a math teacher would know that.
You're not a
English
spell
teacher.
teacher.
I'm not. All right, so these are zeros. They are also, y'all watch, this is important because this is coming up a little bit later. These are the two x-intercepts of the graph. So when we're graphing these things a little bit later, they're x-intercepts, right? Zeros, solutions, also called roots. These four things are synonymous. Okay? So when you solve a quadratic equation, or when you solve any equation, if it's a cubic equation, or if it's a fourth degree equations, the four zeros that we find, or the three zeros that we find, are the zeros of the function. They're the x-intercepts on the graph. So when we start graphing quadratics very soon, maybe end of next week, middle of next week, we'll start graphing these things. Those things are going to come into play. Okay? All right, test tomorrow, and then we'll continue this lesson on Wednesday.